Okay, consider that we have an input x of t, which is equated to e to the at u of minus t, that is going to a system with an impulse response h of t, which is equated to e to the minus at, where a exists strictly in the positive real number domain, and we're tasked to find x of t convolved with that impulse response h of t. And we know that for convolution, we need to take the integral from negative infinity to infinity, x of tau, h of t minus tau, d tau. So this becomes the integral from negative infinity to infinity, e to the a tau u minus tau times e to the minus a t minus tau d tau. This function u of minus tau, if we plot it here, so u of minus tau in respect to tau, is going to be 1 for tau is equals to 0. So it shoots up to 1. And for every value where tau is a negative number, it becomes u of a positive value. So this stays at 1 here and 0 otherwise. As a result, we don't care about what happens over here. We only care about what happens here. So we can change our limits of integration into being from negative infinity to 0 to get rid of this function here, e to the a tau. Let me go ahead and distribute this negative a to t and minus tau. This becomes times e to the minus at times e to the positive a tau d tau. This function e to the minus at is a constant in respect to tau, so we can pull it out. So this becomes e to the minus at integral from negative infinity to 0, e to the 2a tau d tau. If I go ahead and solve this, I get e to the minus at over 2a times e to the 2a tau evaluated from negative infinity to 0. As a result, this becomes e to the minus at over 2a times e to the 2a times 0 minus e to the 2a times negative infinity. E to the 0 is simply 1. E to the negative infinity is 0. As a result, this becomes e to the minus at over 2a. Thank you.